All right, in this video, let's discuss another component of our immune response, and here we'll think about inflammation. So we'll go through the process of inflammation and how we can tell inflammation has occurred, and we'll think about why this process is beneficial. So, inflammation. Inflammation is another component of our immunological second line of defense. So again, this is a normal response to tissue damage and injury to protect our body. So again, we're going to see that tissue damage initiates this inflammatory response, and we'll think about how and why it does that. Along the way, we're going to see that inflammation is characterized by 5 signs of inflammation. So you can tell that inflammation is occurring because there are these 5 signs. We'll think about them individually at the end of the video. We'll think about why inflammation includes pain, heat, redness, swelling, and loss of function. So before we think about how inflammation occurs, let's quickly address why inflammation occurs. So what are the functions of inflammation? So the main point of inflammation is that it's a process that's going to mobilize and attract immune components to areas in your body that are experiencing damage. This is going to allow for tissue repair, and it's going to localize and clear away harmful substances like pathogens. So hopefully we'll destroy any microbes that might be in this area and block their ability to get to other parts of the body. All right, so inflammation is an extraordinarily beneficial process. Now let's think about how inflammation actually occurs. So what are the mechanisms that lead to inflammation, giving us these benefits, and the signs that we've addressed? So we're going to think about what happens at the cellular level. We'll break it into about 4 steps here. So in step 1, we're going to have some sort of tissue damage. So immune cells that detect either pathogens and or tissue damage are going to release chemical signals that are going to initiate inflammation. So we call those chemical signals inflammatory mediators. So again, all over our body, we have immune cells. Immune cells detect that something bad is going on, either that there are pathogens growing in an area or that there is tissue damage. And then to signal for help, they release these inflammatory mediator chemicals, and that's going to start the process. So we get infection or tissue damage, and then we release chemicals to initiate inflammation. Here, the one question becomes, well, how do immune cells detect pathogens or tissue damage? So I just wanted to point out that there are sort of chemical signals of these things. And you might run across this terminology, something like a PAMP, P-A-M-P. So a PAMP is a pathogen-associated molecular pattern. And that's just saying that a pathogen, a microbe that might cause you harm, is going to have a set of molecules on its outside that are unique to that pathogen. Every cell that exists has unique chemical markers on the outside of that cell. So pathogens are no different. So our immune cells are able to recognize these PAMPs, these unique chemical signatures. And our immune cells look at that PAMP and they go, well, that's not normal. It's not normally part of my body. Or they know for sure that it is a pathogen-associated pattern, right? And either way, it signals the immune cells that this thing doesn't belong, and we should initiate an immune response that would include inflammation. So we have pathogen-associated molecular patterns, but you might also see this term DAMP, which is a damage-associated molecular pattern. So if we tear open a tissue, and we'll use this as an example, what if we get a thorn in our fingertip? So we pierce our skin, we tear apart that tissue when the thorn pierces it. We're going to damage cells. The cells are going to get torn open, the tissue is going to get torn apart. That process of tearing open cells or tissues is going to expose chemicals, molecular patterns, that should not be exposed. They're not normally exposed. And so once again, our immune cells can detect that pattern of chemicals that shouldn't be there. And then when they detect them, they can release other chemicals, the inflammatory mediators, to initiate the inflammatory response. All right, so step one of inflammation is we're going to detect that something's abnormal. There's a pathogen or there is tissue damage. And our immune cells are going to release chemicals that initiate inflammation. So here we can see that in a diagram. Here we've got that pierce into our skin from a thorn. That could potentially introduce these pathogens, bacteria from the outside world, into our tissues, so that could be really bad. And the immune cells in the area are going to detect the tissue damage or the presence of the pathogens, and they're going to release chemical mediators of inflammation. And in this particular image, one of those chemical mediators is histamine. So histamine is one example of an inflammatory mediator. So now that these chemicals are released, what happens next? So we'll proceed to the next step. In step two, these mediators are going to stimulate a process we call vasodilation. So vasodilation is quite simple. It's basically just an increase in the diameter of our blood vessels in the area. So this blood vessel is in its normal state, and then during vasodilation, the volume in that blood vessel is increased by quite a bit. So the question becomes, well, why do inflammatory mediators stimulate vasodilation? The main goal is to increase blood flow to that damaged area. So by increasing the diameter of the pipes, the vasculature, we can bring more blood to the area. But why do we want more blood in the area? The main goal here is that we're going to bring additional white blood cells, immune cells, and we're going to call white blood cells WBCs from here on forward. We're going to bring those white blood cells to the area, and that's going to aid in this inflammatory process. The white blood cells are going to protect us. All right, so we stimulate vasodilation. We bring more blood and specifically more white blood cells to the area. In step three, we stimulate another process. Here we're going to increase, the inflammatory mediators are going to increase vascular permeability. So if we can demonstrate that in this diagram, next to our tissue damage where we might have these pathogens, here's the vasculature. It's been dilated, so more blood is coming to the area, but there's also this increase in permeability, and components of the blood are able to leak into the tissue. So vascular permeability allows the white blood cells to leave the blood flow and enter the tissue, where they can then protect us from these potential pathogens. When the white blood cells leak into the tissue, so do other components of the blood, and we're going to have blood plasma, the fluid, leak into this area, and some of our red blood cells will leak through the vasculature and accumulate in this area as well. So we get vasodilation followed by an increase in vascular permeability, and the whole purpose of those two processes is to allow these white blood cells into the area of tissue damage so that they can protect us from infection. So what's next? We've got all these white blood cells in the area. They're going to primarily act as phagocytes to consume and digest potential pathogens. So again, this was the number one goal. Let's get a bunch of white blood cells to this area of tissue damage to make sure that we can remove any potential pathogens from the area. So again, these white blood cells will be performing phagocytosis on these potential pathogens that were introduced. Another benefit, or another thing that's going on here, is that because we brought extra blood to this area, and we let a bunch of the cells and fluid leak into this tissue, the amount of blood that is leaving this area is of a decreased volume. And so that lower volume of blood will actually flow away from this area more slowly. And that's a benefit because if one of these pathogens got into the blood flow, it would not travel as far away from this area of damage as quickly. So this process, by bringing extra blood, letting it leak into the tissue, and then less blood flowing away, actually traps pathogens in the damaged tissue so that we can attack them in one place. It doesn't allow them to spread so easily through the whole body. All right, what else? The plasma that has leaked into the tissue is also going to contain clotting factors. So there are damaged tissue because of the thorn piercing our skin, will initiate tissue repair by forming clots and initiating other tissue repair processes. So that's about the end of inflammation, sort of what happens. I want us to think about why we observe those particular signs of inflammation because of these steps. So remember, in inflammation we see redness, swelling, heat, pain, and loss of function. So let's address these one by one and think about why they are occurring. So we'll begin with redness. The reason inflamed tissue is red is because we brought more blood to the area. So the vasodilation brought more blood. That include red blood cells, RBCs, which creates redness in the tissue. And those red blood cells get trapped in the tissue because of that vascular permeability. So we brought more blood, including the red blood cells. They leaked into the tissue, trapping the red blood cells. And now our tissue, our inflamed tissue, is red. Makes sense, I hope. How about swelling? I think swelling is really a pretty similar explanation. So once again, vasodilation brings more blood to the area. Blood contains fluid or plasma. That plasma leaks into the tissue because of vascular permeability. And that increased fluid content increases the tissue volume. So our tissue becomes swollen because of the vasodilation and the vascular permeability. All right, how about the heat? This one's a little bit less clear. So the first thing I would point out is that heat, any body heat we have, is produced as a waste product of cellular metabolism. So as we do things like cellular respiration, glycolysis, Krebs cycle, and the electron transport chain, every chemical reaction we do produces a little bit of heat as a waste product. So again, the reason our body is warm is because our bodies are doing lots of chemical reactions. So why is inflamed tissue more warm, right? And the key here is that the white blood cells that we're trying to accumulate in this area are amongst the most metabolically active cells in the body. So they're doing tons of chemical reactions compared to almost any other cell in the body. So they produce the most heat. And we've concentrated a bunch of white blood cells in one area. So that one area is warmer than the rest of the body. So we've got redness, swelling, and heat. How about pain? So pain, again, isn't particularly clear, maybe. I think there are two main reasons we experience pain in inflamed tissue. The first is that some of the inflammatory mediator chemicals that are released when we have tissue damage or pathogens in an area, ones like bradykinin is one specific example, they actually increase sensitivity to pain. So they stimulate nerve endings that we interpret as pain. So some chemicals are causing pain. But I would also add that the added tissue volume is sort of squeezing nerve endings. And that can be interpreted as pain as well. All right, the last thing we should address is why do we lose function? So maybe if I pierce my fingertip, I can't bend my finger as much. What's going on there? And really that's just a reflex in response to pain. So when a part of our body hurts, we tend to keep our nervous system keeps us from using that part of the body as much. All right, so we've addressed all of the reasons for inflammation, how inflammation works, and why we observe the specific signs of inflammation. So I hope that gives you a good starting point. As always, if you have any questions, I hope you'll let me know, and I'll talk to you all again very soon.